Hey, welcome back to the Caribou Data Science channel on YouTube. This is the evening of Thursday, January the 12th, 2023. And as the title suggests, we're going to continue to work our way through the WorldQuant-University's Data Science Lab. We're in the midst of Module 2. Let's sit back, relax, folks. I'll be back with you in like 15 minutes, okay? Okay. All righty. Welcome back to the Caribou Data Science channel again. Before we get started with tonight's activities, we're actually going to, well, let's just get the right screen up here first. Okay, there we go. Okay. Now, before we get started, we'll take a brief look at a question I got uh, uh, on a YouTube video I posted a comment to. Okay, I made a mistake of of posting a response to an article about about Unix shell scripts. Okay, so anyway, let's take a look over at the video at the question. So the title was comments on filtering log files with cat grep sort. Well, this is exactly what I did. Okay, I said, back in the nineties, that's so we're talking what 30 years ago. I wrote a script to track back up, and someone says, "Please show us." Okay, well, okay, and the question was, uh, well, how do you do that? Well, you do exactly what it says up here. Okay. uh, I've actually forgotten most of what it. Well, actually, I wouldn't say I forgot. It was kind of like buried in the back closet. Hopefully never to rear its head again. Well, the answer was uh, use cut, use sort, and use unique. Okay, so what it is. Let's see if we can do something here. If memory serves me correct, if you want to do for simply one file, you would let's say it's one of them cyclistic bike share files. Okay, and so we want to start with column. First, we want to uh, specify our delimiter. Then we want field 3. Okay, we're going to pipe that a sort just for the fun of it. Dash C. Now this is the real beauty part right here. Dash C basically does a count of the unique values. I mean, it counts it does it well in the case of say a log file, a backup file. It would count the number of times each tape occurred. If field 3 was a tape number, it would count the number of times each tape uh, occurred in that log file, which is okay, unless of course you got a directory full of log files to import. This is where my mind starts to get a little bit fuzzy here. But anyway, you do a for x in, let's just say log, right? You do a do. Well, what's missing here is a file name. Okay, this is a file name, and that's what x is. That's what this x gives us a list of the files. X gives us a list of the files. All right. Now, I don't have a way to test this right now because fortunately I don't have Linux installed. The memory serves me. So you have to come over here, and what you're going to do, you're going to pass uh, something like x, say x, which is going to give us the log file name. Okay. Then you're going to do an append. Tape report or something like that. Okay. Then you come down here like this, right? Now what you got is let's go loop through this directory. Okay, you might want so you'll put this script in the same directory where your log files are. Either you have to use a pass statement. Okay, so it's like every file in that directory has a .log extension, and pass it through this cut function here. Pull out the third column, sort it by date, do unique count, and it's going to keep appending each log file is going to be appending onto into this file right here. When it's done, it does it done. Okay, so that's basically the answer. But I'll see what happens. If someone comes back and actually asks me a second question about it. Oh, I thought I answered that person's questions. We'll see. Maybe I just can't see them. Okay, but anyway, there's your Unix strip for. There's your Unix lesson for the US shell scripting lesson for tonight. And that, to me, that's actually a really good use of Unix scripting at the most basic level. Okay, Buenos Aires housing. Open this. Now let's get back to the subject at hand. Did you really get down on your knees, begin to play? Right. So we're somewhere. Where did we leave off over here? So we made it down to 219. 219. Okay. Let's see. Create a target vector named yTrain, which you will use to train your model. Your Of course, in order for this to work, I have to come all the way back up here someplace, don't I? We're getting close. That's encouraging. It's still working so far. The new scatter plot. A little seaborne action. features. That was 218. So now we're up to 219. Now, again, I want to say this really isn't. I've been really impressed with the quality of this of the videos and the project so far, and it's even more impressive that it's completely free. I mean, there's no beggarware, there's no donation tab. It's just free. Okay, but anyway, you click over here. Then.
All right, time for the target vector. So here, notice that we're using y, and it's a lowercase y, so big X, little y, but we're still using the underscore train to remind us that this is our training data, not our testing data. Now, before with features, we had a list. Now, for our target, we're just doing the string. Now, why is that important? Well, if I do df and then square brackets target, and then I look at yTrain.head, what we'll see is this is a series, right? This is a series, not a data frame. And if I look at the shape of this series, I can see that we have 1,343 values in it, but after this comma, there's nothing.
1 sec. I'm gonna go to the restroom and put a warmer shirt on here. species. Hmm. That's really strange. I thought I replied to that. Okay, let's go back over here. Hmm. That's a little disappointing that I didn't actually save that answer. There. I've done my duty to the Unix community for tonight. Now let's come back over here to this rascal over here.
Nothing else, right? So there's only one dimension. This is a vector, right? That tells us it's a vector. And so if I put this in my, if I put this in the assert statement here and try to run this, I can see that nothing happens. So that means I'm good to go. I've split my data into my big X, my little y, my feature matrix, and my target vector. And now I'm ready to actually begin building my model.
First step, we already did that, didn't we? Why don't I have it over here?
If you're like me, you've been waiting weeks. You guys have been working with Project 1, now you're in Project 2, and we finally get to build our model. So I'm super, super excited that we get to do this together. Now, remember that there are 3 different parts to building a model. Baseline, iterate, and evaluate. So let's start with our baseline. Now, the idea of a baseline is that you want to get a sense of how good does your model need to perform in order to be useful to your stakeholders. So you're basically setting a baseline for performance that your model needs to beat in order to be worth it. All right? So with that in mind, let's go here to the old notebook. And in order to create a baseline, the first thing we need to do is we need to ask ourselves, is this a regression problem or a classification problem? So if it's a regression problem, the thing that we're trying to predict, our target, is some sort of continuous value.
Yeah, we do this the other night, but for whatever reason, okay, none of it was recorded. None of my notes were kept. Let's just go through it again then.
For example, the price of an apartment can range between $0 and, millions of dollars, depending on the apartment. So this is a regression problem. Now, if it were a classification problem, that would be different, right? Maybe we were trying to predict whether an apartment would sell in the next 6 months, right? The 2 choices are yes or no. Those are 2 categories. So we would be doing classification. But in this case, we're doing regression. And so what that means is that in order to set our baseline, we need to start by finding what is the mean value for our Y train.
Mm-hmm.
So when you're setting a baseline, the first thing you need to ask yourself is this a regression problem or a classification problem? So like a classification problem would be if you're trying to predict whether or not an apartment has clean floors or dirty floors based on, the size of the apartment or where the apartment's located. There are only 2 choices, clean or dirty. Now, if it's a regression problem, the thing that you're trying to predict, your target is a continuous value. For example, the price of an apartment can go between 0 and, millions and millions of dollars. So this is a regression problem. All right. Now, what does this mean for our baseline? Well, a good way to think of a baseline model is kind of like a dumb model, or we call it a naive model because we don't want it to feel bad. We want it to have good model self-esteem. So we call it a naive model. And the idea of a naive model is that it can only make a single prediction. No matter the size of the apartment, no matter what the apartment looks like, it's always going to just come back with the same prediction. And in the case of a regression problem, a really good prediction to always make is just make the mean price your prediction. So if I zoom in here, what we could do is I could do Y mean. Well, I could take my Y train and do dot mean. And I'll do Y mean here, shift and enter. And what this tells me is that the mean apartment price in our data set is around $135,000. And so for our naive model, what it's going to do is it's going to say, okay, every time I see an apartment, I'm just going to predict that its price is going to be $1,330.
So we actually did part of these last night. Unfortunately, I didn't save it in my notes, so we'll go over it again here just to make sure we got it down pat.
$5,000. All right. So now we have that guess that our naive model is going to make over and over again. And then in the next task, let's actually see how we would evaluate this model.
Now that we have the one prediction, yes, I'm listening, that our dumb model will always make, we need to generate a list that repeats the prediction for every single observation. So this brings us down to 211.
All right, we're establishing our baseline. We know that the mean apartment price for our training data is $135,000. And so now we need to make our model predict that number over and over again. So if I zoom in here in our notebook, we know what our mean apartment price is. We have it highlighted up here. And now we just need to make a list of predictions of that number over and over and over and over again. So let's go here to yPredict baseline. So yPredict baseline, and we want to take y mean. So we have our y mean, and actually let's do yPredict baseline here just so we're kind of we see what our output is. There we go. Beautiful. And let's see. Next thing is we actually need a list, right? So why don't we take y mean and let's put it inside a list. All right, awesome. We're getting there. Now, it's a list. It has one prediction in it, but we actually want a list of the same prediction over and over again. And we want that list to be as long as our Y-train data set. So what that means is that we're going to do y mean, we have it inside a list, and we're going to multiply it by the length of y train. We'll multiply it by the length of y train, and now this is going to be a long list, so I don't want to look at all of it, so I'll use my square brackets and just say, give me the first 5 values. Beautiful. All right, so what I have, or what I now have, is I have a list, and if I just check out the length of this list here, there we go, y train, beautiful. And let's just make sure that this is the same size as our y train, so 1,343. Yep, true, excellent. Okay, so we now have our list of predictions. Let's see if we can visualize what these predictions look like. All right, we're establishing our baseline. We know that the mean apartment price for our training data is $135,000. And so now we need to make our model predict that number over and over again. So if I zoom in here in our notebook, we know what our mean apartment price is. We have it highlighted up here. And now we just need to make a list of predictions of that number over and over and over and over again. So let's go here to yPredictBaseline. So yPredict baseline, and we want to take yMean. So we have our yMean, and actually let's do yPredict baseline here just so we're kind of we see what our output is. There we go. Beautiful. And let's see. Next thing is we actually need a list, right? So why don't we take yMean and let's put it inside a list. All right, awesome. We're getting there. Now, it's a list. It has one prediction in it, but we actually want a list of the same prediction over and over again, and we want that list to be as long as our y. We figured out what the mean value is of our target, our little y, and then we created a list, yPredictBaseline, with that value repeated over and over again. But it would be better to kind of understand this as our baseline model if we could actually make a visualization of it. So here we are in the notebook. I'm on task 2.1.12, and I will zoom in. And the first thing that I'm going to do is I'm going to run the code that we have here as is. And if I do that, we can see that we have a
Hot message coming in on
scatter plot, and unpacking what's on this scatter plot, along the x-axis we have our apartment sizes, and then along the y-axis we have our apartment prices. And so what we can see is that every dot, every point in this scatter plot has an area, the size of the apartment, and then it also has a price. So if we're going to plot out a line, we need to provide both x and y coordinates. So now let's think about how we're going to plot out the line that is our baseline model. I'm going to scroll up here, and I'm going to start with plt plot. This is always the way you start when you want to plot a line in matplotlib. And then I need to give x and y coordinates. Now, with our x coordinates, we know that they are here in our big X train, all right, in our training feature matrix. So we can put them in there. And then all of our y values for our baseline model, remember it always predicts the same price, whatever that mean is. So we'll do yPredictBaseline. And if I hit shift, and actually before I hit shift and enter, let's add a couple other things here. So first, let's add a color so that it contrasts with the blue. So let's have an orange. And then let's also add a label here so that we can see what this line represents. And we'll just call this baseline model. All right, beautiful. So now that we have all of that passed in, let's hit shift and enter here. and we get a type error. Let me zoom out and see if we can investigate what's going on here. I'm going to scroll down, and I always go right to the bottom, and what I can see here is invalid index error, slice, 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 none. Now, this isn't a particularly helpful error, but what this is suggesting to me is that matplotlib is having trouble slicing or finding the data that we're passing in. So maybe the problem is that we're passing it in the wrong way. I'm going to scroll up to kind of show you what I mean, and then we'll kind of go from there. So here's our original code, and I'll create a cell up above where we were working, and then I'll zoom in, and let's start with xtrain. Now, if we look at the type, so the data type here, xtrain is a data frame. So if we look at xtrain.head, it looks like a data frame. And if we do xtrain.shape, we can see here that it has 2 dimensions. And it kind of seems like maybe matplotlib is having a hard time accessing data in a 2-dimensional data frame. Maybe it just doesn't like data frames at all. So there are a couple ways that we can get around this. One thing that we could do is, if we again just look at head here, and what we can see is that, yes, this is a data frame, but actually there's only one column in it. And that's the only column that we want. So instead of passing in the whole data frame, we could just pass in one column. So if we passed in surface area covered dot head, there we go. So this gives us a slightly different data type. In fact, if we look at the type here, we can see that it's a pandas series, which is a fancy word of saying it's a column from a data frame. So one thing that we could do is we could just pass in this series and see if that works. Let's try that. I'll hit Shift and Enter. There we go. Now it's working. Okay. So that's one way that we can do it. And then another way that we can do it is if you look up at xtrain, if you ever want to get the values out of a data frame without all of the other stuff that comes with a data frame, you can always do xtrain values. And that doesn't return a data frame. It doesn't return a series. It returns something called an ND array, which is basically like a fancy list. We'll sort of be learning about NumPy and ND arrays kind of sprinkled throughout this program. So if we look at this here, let me just look at the first couple values here. So maybe 1. No, that won't work. Let's look at 1. Let's look at the first, I don't know, say 5 values here. And we can see here that this is sort of like a column, but it also looks kind of like a nested list. So it might be that matplotlib would be happier with the values in this format. And so if I do xtrain values and I paste them in, I think we should get the same thing, and indeed we do. Awesome. So those are 2 ways that we can work around the issue of matplotlib not wanting to plot out a data frame or data in a data frame. Now, turning to this actual model itself, what are we seeing here? What is represented? Well, what we see is that no matter the size of your apartment, our model will always predict this particular price. So it looks like around 140, something like that. And so this is what our model looks like, all right? If we were to plot out our line, this is what it looks like. Now, looking at this line here, do you think that this is following the trend in the data? Do you think this line is doing a good job of making predictions? And a follow-up question, why do you think it is or is not? What is the visual cue here that you're looking at that's telling you that this is a good or not a good model. So yeah, a lot of you are saying, and I think you're right, this line is flat, but our data seems to have more of a slant to it. That is to say, as apartments get bigger, they tend to get more expensive. And so this is okay for our baseline model, but as we'll see in following tasks, when we train our model, we'll get much better performance. Now, one last thing I just want to say, here we're looking at this visually, we're assessing our baseline visually, but as data scientists, we can't just rely on visualization alone. We need to think of some sort of mathematical or numerical way to assess the performance of this model. So that's exactly what we'll be doing in the next task, and I'll see you for that in the next video. All right, things are getting exciting. Why? Because we've taken our data and we've split it. We have our feature matrix area, we have our target vector price, and we are going to try to use area to predict price. Now, we created a scatter plot to see if there was some sort of correlation there. We did see something, and so when we were creating our baseline model, we started with the mean price in our training data, and we plotted that against the data. Now, we see that our model, this baseline model, doesn't really follow the data, so we know it's not a great model, but we need some sort of numerical evaluation of the performance of this model, and that's where performance metrics come in. So, like the name implies, performance metrics are a way to measure the performance of your model. What metric you use depends on the type of problem. There are metrics for classification, there are metrics for regression, there are metrics for everything. But one of the most popular metrics or most used metrics for regression problems is mean absolute error. So let's just take a little bit of a deep dive into mean absolute error, and then we can actually write the code. So here is a picture of our model. And what I'm going to do is I pasted it here onto my Blackboard because I want to think about how this is all calculated. So let me make some room here on my desk. Sorry, guys. Sorry. Live TV. What are you going to do? All right. So what I have here is the way that mean absolute error works. So let's just call this MAE for short. The way mean absolute error works is, on the one hand, I have what are the true values of my data. So these blue data points that you see, these are the actual data. These are the actual prices. And then with that, whoops, I don't know what happened there. With that, I have my predictions. And actually, whenever I want to symbolize in math talk that I have a prediction, I put this little hat on top. This is the prediction hat. All right. So whenever you're a data scientist, you have to put on your prediction hat whenever you're doing machine learning modeling. So I have my prediction, and then looking in on this data, let's take the example of this data point here. So notice that this data point is up at around $250,000. And notice that the prediction for our model puts it at around 100 and whatever it was, our baseline was 140 something, 130 something, I don't know. So there is a difference here. There is a difference. And if we were going to evaluate this difference, right, we would say that this number here is higher than this number here. So we have some sort of positive difference. In this case, it's a difference of like, $100,000. All right? Beautiful. So that's what happens when our model underestimates the price. We get this difference that's a big positive number. Now, what if we have an error that's goes the other way? Here's another data point, and we can see that the actual value is somewhere at around under 50,000, whereas our model is predicting something much bigger, again, at around 140 something or whatever it was. And so here, we're going to have a very big negative number. So if we do this for all of our data set, we're going to have a bunch of positive numbers and we're going to have a bunch of negative numbers. Now, we don't want these numbers to cancel each other out. We want to take all of this error and add it together. But if we add together a bunch of positive numbers and a bunch of negative numbers, they're going to cancel each other out. So what we do is let me just move this over a little bit. Beautiful. So what we do is we take the absolute value. We take the absolute value of that error. And what we'll do is we're just going to sum up. This is the little epsilon, the little sum up thing. We're going to sum up all of those errors, and then we're going to divide them by the number of data points in our data set. All right? So we take all the differences between our model and the actual values, between the predictions and the actual ground truth. We then add them all up. We take the absolute value, we add them all up, and then we divide them by the number of data points in our data set. And so what we're saying is, on average, our model is wrong by about this much. Now, what's a good mean absolute error and what's a bad mean absolute error? Well, a good mean absolute error is going to be somewhere right at around 0. So that's going to be something where it's like, if you have a model that looks exactly like this and the data points follow your model exactly, then you're going to have a mean absolute error of 0. So 0 is what you want to shoot for. You want to get as close to 0 as you can. By the way, if you get an actual 0, something is probably wrong with your model. I would just check. But you want to get close to 0. And then mean absolute error can be as big as, who knows? It can be as big as you want, right? It can be as big as the data allows. So there's no upper bound on mean absolute error. All right? And then the other thing that's important to remember is that mean absolute error, the unit of measurement, is going to be whatever the unit of measurement is for your y-axis, the thing that you're predicting. All right? So our mean absolute error is going to be somewhere between 0 and infinity, and it's going to be in US dollars. All right? So that's mean absolute error. With that in mind, let's go back to our notebook and let's actually put together the code here. So I'm going to scroll down to where we are. Beautiful. And the way I'm going to calculate the mean absolute error is I'm going to take that mean absolute error function that we imported from the metrics module in scikit-learn. So I'll do mean absolute error, and mean absolute error takes 2 arguments. The first is it takes the true labels, so the true values, y-train, and then our predicted values, which in this case is y-predict baseline. Beautiful. And then what we're going to be doing here down below is we're going to print out 2 things. We're going to print out the mean apartment price, just so we have an idea of that. And then we're going to print out our baseline. And notice here that I'm just going to round these to 2 decimal places just so we don't have a lot of decimal places here. So if I hit Shift and Enter, I can see that our mean apartment price is around 135,000. So 135,000, and what my baseline mean absolute error is telling me that it is that if I guessed 135,000 for every property in this data set, on average, I would be off. My estimates would be off, my predictions would be off by around $45,000. All right? So this means that in order for our model to be useful, we want a baseline, we want a mean absolute error, not a baseline mean absolute error, a mean absolute error that is less than $45,000. All right? So the die is cast. We know what we need to beat. So let's begin making our model. One misconception that some folks have when they start studying data science is that it's all about the models. You know, they're like, oh, I can't wait for hey, bro, have you seen the models? Where's that, bro? Now, sometimes because they think this, they think that like by far the hardest part, the most difficult part is like building these models. Oh my goodness, it's going to be so hard. But I'm going to lay a little bit of truth down on y'all, which is that most of what data scientists do isn't building models. About 80% of your work is going to be connecting to databases, pulling data, reading in CSV files, wrangling, cleaning, right? And building models, while a very important part, is not really always the star of the show. And that's actually kind of a good thing because building models just isn't as hard as you think it is. So why don't we go to the notebook here and let's build our first model. Now, there are kind of 3 steps to building the model, all right? The first is we need to instantiate the model. That is to say, create a model that we can train. The second step is to train that model. And then the third step is to use that model to predict. So instantiate, train, predict. So let's start with instantiating. And I tell you what, this is going to be a little bit of an anticlimax because remember up above, we imported the linear regression class. So what I'm going to do here is just do linear regression, and I'm going to do open and close parentheses because I don't want to add any extra arguments. I want to keep everything as default, and then I'll hit Shift and Enter, and that's it. My model is instantiated. And if I run the next assert statement just to check my work, I can see that we're set. So my model's instantiated, and now I'm ready to fit. One misconception that some folks have when they start studying data science is that it's all about the models. You know, they're like, oh, I can't wait for hey, bro, have you seen the models? Where's that, bro? Now, sometimes because they think this, they think that like by far the hardest part, the most difficult part is like building these models. Oh my goodness, it's going to be so hard. But I'm going to lay a little bit of truth down on y'all, which is that most of what data scientists do isn't building models. About 80% of your work is going to be connecting to databases, pulling data, reading in CSV files, wrangling, cleaning, right? And building models, while a very important part, is not really always the star of the show. And that's actually kind of a good thing because building models just isn't as hard as you think it is. So why don't we go to the notebook here and let's build our first model. Now, there are kind of 3 steps to building the model, all right? The first is we need to instantiate the model. That is to say, create a model that we can train. The second step is to train that model. And then the third step is to use that model to predict. So instantiate, train, predict. So let's start with instantiating. And I tell you what, this is going to be a little bit of an anticlimax because remember up above, we imported the linear regression class. So what I'm going to do here is just do linear regression, and I'm going to do open and close parentheses because I don't want to add any extra arguments. I want to keep everything as default. And then I'll hit Shift and Enter, and that's it. My model is instantiated. And if I run the next assert statement just to check my work, I can see that we're set. So my model's instantiated, and now I'm ready to fit. I've instantiated my linear regression model and assigned it to the variable name model, and now I need to train it using my training data. So what I do is I do model, and then after that I do .fit, so I use the fit method, and then I need to put in the name of the feature matrix and target vector, the big X and little y, that I want to use to train the data. So in this case it's X train and Y train. So I'll hit so what I'll do is once that's done, I'll hit Shift and Enter, and you see that we get a little bit of output here, and that output lets us know that our model has been trained. And if I also want to check my work, I can run the cell below here, which is it's kind of like an assert statement, except it just doesn't say assert. But if I hit Shift and Enter, it runs, so I know my model is fit. So I've Oh, are you guys excited? We've got this model. We're finally going to start making predictions. I can't wait. Let's just dive right in. I'm not even going to do an introduction. I'm so excited. So we've instantiated, we've fit, and now we need to do predict. So what I'll do is I'm going to do model model.predict, and inside the round brackets after predict, I want to put in a feature matrix, and I want to put in a feature matrix that I want to make predictions for. Now, sometimes you use test data to make your predictions. In this case, just for since we're learning these concepts for the first time, we're actually going to use our training data. So I'm going to put in the feature matrix xtrain, and we're going to see how our model performs on the training data versus the actual targets. So I'll run this cell, and what we'll see is I'm going to get just the first 5 predictions that my model makes. Let me zoom in here. So like the first property, it says it was 169,000. The one after that, it said it was 106,000, and so on. And so forth. All right. And since we have 1,343 data points in our data set, we should have that many predictions. Which means if I run this cell down below, it should work. Beautiful. Okay. So we've instantiated. All right, model evaluation time. So we're evaluating this model using the training, we're using the mean absolute error. And so what we'll do is we'll do mean absolute error again, except this time, we'll still have y-train, but the difference is instead of y-predict baseline, we'll do y-predict training. Y-predict training. And now we're going to run this cell to see if we can beat the prediction here. See if we can beat that 45,000. And oh, we did! Party time! Excellent. So this is 31,000 is our new mean absolute error. We beat the baseline by over 10,000, which means our model is really adding value here. Beautiful. Excellent. Okay, we have our model, we have our performance metric. Let's see how this compares visually to our other model.
Okay, I'm actually going to save the last section here, 220 onward, for well, you know what? This is Thursday night. Oh wow. Well, probably till Sunday night. Okay, so hopefully I see you back here on Sunday evening, if not Monday evening. Again, the regular schedule is the official schedule is Monday through Thursday, 8 p.m. Eastern time. But I may come back on Sunday night just to do a bonus section to wrap up this last portion of section 021. Okay. Is there anything else we can do this evening? So, my friends, uh, I'm going to bring this session to a close tonight. It's a short one. What's the time online? 1 hour 39 minutes. So anyway, hey, thanks much for stopping by. Be sure to check back uh, to Sunday night. If not, of course, you got the bell click next to the on the bell icon. Click to be notified whenever I go live. But the plan is probably Sunday night, certainly Monday night onward. Okay.